Hi friends, we're in Unit 1 of College Algebra and then Day 2 notes. This one's going to be focusing on specifically linear equations and inequalities. First, the set of numbers that satisfy an inequality is called the solution set. So we can actually have different formats or ways to represent the solution set. And so for the inequalities and solution sets, one of the ways is interval notation. So the interval notation here, this is not an ordered pair, this is interval notation. So if I say interval notation of the solution set, it's 1, parentheses 1, comma 2. That means that on a number line, that is from the values of 1 non-inclusive to 2 non-inclusive. So on a number line, we use these open dots to represent that. For set notation, we have brace the set of x such that 1 is less than x is less than 2. Another way that we would say that is x is between 1 and 2, both non-inclusive. For the next one, this bracket here in this notation is inclusive. That means we would fill in the dot, and again leaving 2 open, so this is from 1 to 2. 1 inclusive to 2 non-inclusive. And then, very similar for set notation, the set of x such that 1 is less than or equal to x is less than 2, or 1 inclusive to 2 non-inclusive. And then for the next one, we're kind of combining this for both values. So now 1 and 2 are included in our solution set. And so the way that we write this, again, filling it with our number line, we fill in both circles. And then the set of x such that 1 is less than or equal to x is less than or equal to 2, or the set of x such that x is between 1 inclusive and 2 inclusive. From this next one, we have 1 to infinity. I always ask that you use at least 2 numbers on the number line to give it kind of a depth, so a reason. And then, sorry, it's 1 non-inclusive, I apologize, to infinity. That is an open dot, not a closed dot. My apologies. And then we fill in, and then I always fill in past the arrow to show that as well. So just like that. And then for this one, we would say the set of x such that x is greater than 1. And that's all. And then from 1 inclusive to infinity, again, very similar. I have my 2 circles. Now I fill in my circle, my dot. I'm actually showing that that point is included. That's what I'm saying with that. Then I have the set of x such that x is greater than or equal to 1. And then now for negative infinity to 2, got my number line ready. So what I have is from here, I have negative infinity to 2, so let's do 0, and then, not 2 like that, I apologize. 2 here, let's see, 2 is not included, and then the solution sets are all the values that are less than 2, so I have the set of x such that x is less than 2. And then for this one here, so I have 0 and 2. Now 2 is included. 2 is included in this. And so now it's less than or equal to 2. The set of x such that x is less than or equal to 2. Then this last one here, this one shows for interval notation, if I have all the values. So this, all of the points are included, so the entire number line is shaded. For this one, we have the set of x's such that x is an element of the real numbers. So in this case, we're saying that x is a part of all of them. For this example, if we were looking at something without a solution, so there's no solution at all, for interval notation, it would be missing. There would be no interval. So the interval shows where it is a solution. On a number line, so for this last one, there's no solution. It's hard to see because it's hard to draw there. So for this one, our number line would be blank, because there would be nothing on it. And then the set of x's such that x is an element of the null set, or the empty set. So that would be for that as well. Join me in the next video as I go over example 1. Have a great day.